Okay, Pascal's triangle. It's just a convenient way to remember the pattern for binomial coefficients. So it looks like this, and you will need to know how to form it, but it's really not that hard to form. Notice your first and your last numbers are going to be ones all the way down. So your first number and your last number is always going to be a 1. And then every other number in the row is formed by adding the two numbers immediately above it. So like here we see we got 1 and 1. When I add them, that gives me the 2 there. When I take the 1 and the 2, they add to give me the 3. I can pick anywhere in here. The 10 and this 5 will give me that 15. You know, I mean, I could say here, the 35 and the 35, well, I know in my next row, there's going to be a 70 there because of it, okay? And so we could actually go ahead and let's do that. Let's form our next row. So we know it's going to be a 1 on the outside, and 1 plus 7 is 8, and 7 plus 21 is 28, and 21 plus 35 is 56, and we already said 35 and 35 is 70, and then 35 and 21 is 56, 21 and 7 is 28, and 7 and 1 is 8, and it always ends in a 1. Now if you notice, it's just like we talked about before with the binomial coefficients. We said they're symmetric, and if you notice that, it is symmetric about the middle there, and that middle is 70 on this one. So there is a relationship between Pascal's triangle and our binomial coefficients. So looking back at what we looked at towards the beginning, of course we only looked at x plus y through the 5th, and now they've taken it through the 7th. But notice they wrote it out again, but this time they took and they took your coefficients for each one, and they didn't just leave it as x plus y. They left it as 1x plus 1y, and they put those coefficients in pink. So look at your numbers. You got a 1 in the first, the row that's written first, and then the next one you have a 1 and a 1, and then you have a 1, 2, 1. Those are those numbers that are in that Pascal's triangle. So it works for binomial expansions. The only thing is, now notice, like I had mentioned earlier, everything with binomial coefficients starts with a 0. A sub 0, 0 row right here on our in our triangle, okay? And that's because this exponent is a 0. Then we have our first row, then our second row, then our third row, etc. We could go on down, and this one here would actually be our 7th row. Alright, so then something else, notice, I'm going to back up to the other one, it's a little easier to see it. But if you look back at this one here, remember now we just said that this was our 0th row, and this one here was our first, and this one here is our second. And we could keep going. I'm going to do one more, so this is my 3rd row. Notice what the second number in each one of them is. In the first row, your second number is a 1. In the second row, the second number is a 2. In the third row, the second number is a 3. And it keeps going like that if you look, as you keep counting. And also you can notice in the 0th row, what is the second number? Well, it doesn't really have one, so we could think of it like it's a 0, even though it's technically not written, okay? There's no number there, so it's the 0th row. Another way, so this is the way I know if I'm asking you to find something in the 12th row, then you need to keep going until that second number is a 12.